Okay, we're going to start off this lesson a little bit different. Suppose you work for a company and make $11.50 an hour. In other words, the more hours you work, the more you would earn. This is really a function and can be written in function notation. In other words, your earning is based on the hours. In other words, hours is your input. And your earnings would be 11 and a half times your hours that you work. Now, typically, we don't write functions with full words. There's nothing wrong with it, though. But for the most part, mathematicians are lazy, so they're going to abbreviate this and write it as E of H, where E is representing earnings and H is representing your hours. So this is function notation. Once again, E is earnings and H is hours. So we have our function that's predicting what we earn based on our hours. Now, these are also functions. We have A or F here in red, we have G in blue, and we're going to look at doing operations with these functions. In other words, we want to start out by adding these functions together. So we need to take our red F and our blue G and add these together. Well, if we're just adding, all we have to do is combine like terms, and we would get this. Over here, we need to take the red and subtract the blue. So F minus G. So we take our red minus G. Remember, if you're subtracting, you got to subtract that whole thing. So we really have to go ahead and distribute the negative sign through into the blue parentheses. We get this, and then we can just collect our like terms. Here we have F multiplied by G. So we need to take the red multiplied by the blue. And then all we'd have to do is 2 terms times 2 terms, FOIL. Multiply the first terms, multiply the inner terms, multiply the outer terms, and your last terms. Here we need to take the red divided by the blue. So we want to take the red divided by the blue. Now, there's nothing we can do at this point to simplify it. It has no common factors top and bottom. Yes, we could factor the bottom into x plus 1, x minus 1. We could take an x out of the top, but it doesn't allow us to have any common factors. Now, factoring the bottom into x plus 1, x minus 1 does allow us to realize what it is we can't use. We can't let the bottom be 1 or negative 1 because that would cause the bottom to be 0, and we can't divide by 0. Now, if you have ever shopped at Kohl's, it's common for you to get Kohl's Cash, which is so many dollars you can take off your purchase. And it's also common for you to have a coupon of a percentage that you can take off. In this situation, we're going to have $10 in Kohl's Cash, and we're going to have a 20% off coupon. So our coupon function is going to be our coupon times whatever our price is. Now, our coupon is 20% off. You're getting rid of 20% you don't have to pay. That leaves you 80% to pay. So that's why it's 0.8 times your price. Your Kohl's Cash just says, I don't care what your price is. You just take off $10. Now, typically, you can use both the coupon and Kohl's Cash on a purchase. So, does the order in which you apply these make a difference? So, let's consider a situation where we have $120. Now, let's consider having our Kohl's Cash that we use first. Then we use the coupon. In other words, we're going to have our Kohl's Cash that we're plugging into our if I can talk here, sorry about that, plugging into our coupon function. Now, our Kohl's Cash just says we got to take our input and subtract 10. That's what we have. But we need to take that and plug it into this. So we got to take that x minus 10 and it gets plugged into here because we're taking one function and plugging it into the other function. Now, let's see what we would get if we went ahead and plugged in 120. If we plugged 120 in here, we'd have 120 minus 10, which is 110 times that 0.8. So that would then give us $88 we would have to pay. But what is it if we go ahead and we do the coupon first and then we do the Coles cash? In other words, we're doing our coupon first, taking that answer and plugging it into the Coles cash function. So we need to do our coupon first, which is taking 80% of it, and then we're going ahead and subtracting the $10 after that. So these are the two functions we would have. We worked out the top function for our $120 price. Let's go ahead and work out our bottom function for our $120 price. So we're going to put 120 in here, take 80% of it, and then subtract 10. Well, in that case, we get $86. So it's better for you if they do the coupon first and then the Kohl's cash. But however, the store's into making money. Which way do you think they're going to do it? They're always going to have you do it this way here because they're going to get a little bit more money. They're always going to do the cash first before the coupon. Now, when you put one function into another coupon, that's really, or one function into another function, that's really considered a composition of functions. That's what we're looking at here. In this case, it means we're taking whatever g is, and we're plugging that in as our input into function f. So here, we'll look at that down here, but just let's review what function notation is. This says we need to go to function g, and we need to go ahead and we need to plug in 2 for all of our inputs. Did I say function g? I mean function f. So we go to red function f. We got to plug in 2 for all of our x's here. And then we can simplify that down, and we would get 4, or 28. Down here, it says we got to go to function f, plug in for all of our inputs, triangle. Here we have function f. Whatever our input is, we want to put in box. So we want to do that same idea down here. Whatever our input is, which in this case is a blue g of x, we want to plug that in for these boxes here, or for these x's. So we have g, because g is x squared minus 1. So I did that. Now I want to take, just a second here, this blue and plug it in for each one of these boxes, or each one of these triangles, or each one of these x's. So my original function f that I'm dealing with here says 3 times my input squared plus 7 times my input. So 3 times input squared plus 7 times my input. My input is the blue stuff in the parentheses, and that's what goes in here. All I have to do now is just simplify this. I could distribute through the 7. Remember, squaring means multiplying it by itself, so I have to FOIL x squared minus 1 times x squared minus 1, which is not quite right here. So just a sec. There we go, because an x squared times an x squared is my x to the 4th. Distribute through the 3. Collect my like terms, and I get this. Try to do this second one over here on your own. Go to G, plug in 3. Go to G, plug in triangle. Go to G, plug in box. Now down here, I want to look at what is in the parentheses. Well, that's just my red stuff. So I need to go ahead and deal with G. G says whatever my input is squared minus 1. Well, my input is this red stuff, so I got to put that in the parentheses. Now I'd have to go ahead and square that, so I'd have to FOIL that out, multiply that out, and I get this here. I have no other like terms, so that's it. Now, we have 2 more problems down here. It says f of g of 2. So you start from the inside, work your way out. So you figure out g of 2. Well, I got to take 2 and plug it into g. Remember, g is input squared minus 1. So input squared of input 2 squared minus 1. So that's just 3. So now I need to go to function f and plug in 3. So I plug 3 in for all my x's, simplify it down, I get this. We could go ahead and do the other one here. We need to go ahead and plug in our 5 into the inside of f. So, oops, just a second here. Had an extra F hanging around there, so I take 5, plug it into F. F is the red, take 5, plug it in, simplify it down, I get this. So I need to go ahead and go to G and figure out a G of 110. So plug 110 into G, simplify it down, and I get this.